So, number 1, you should have gotten y equals negative 4/5 x plus 13/5. Is that one okay?
Yeah.
Plus 13/5.
Yes.
Okay.
Number 2. So, we have y, think of that as y times the sine of 3x equals x times the cosine of 4y. So we have to do product rule. So if I start at the beginning, derivative of the first, derivative of y is 1 dy dx times the second plus the first derivative of the second. Derivative of sine is cosine. Angle stays the same, but you have to do chain rule. Derivative of the inside. Derivative of 3x is 3. Is everybody with me there? Now we do product rule on this side. So derivative of the first times the second plus the first derivative of the second. Derivative of cosine is negative sine. Inside stays the same times derivative of the inside. Derivative of 4y is 4 dy dx. Okay. Is that going to be too much if I factor out my dy dx and move them to the same side?
That's what I do.
Okay, so this is my sine 3x. I'm going to move this term over here, so that'd be a negative 3y cosine 3x plus my cosine 4y. This term is getting moved over here, so it's negative, so we add it, 4x sine of 4y. Okay, did I lose anyone in that step? I kind of reordered things within the term and moved them around.
So I do these problems.
So then to get dy dx by itself, you divide. And we get to there.
I was doing it wrong because I was skipping too many steps, so I wasn't subtracting. I was putting my minus.
Oh, yeah.
But it's okay. 'Cause
Skipping too many steps is dangerous. Signs get lost.
Someone helped me, so I got the right answer.
Is that okay? So number 3, we have y equals x natural log of y plus x. So think of this as x times the natural log of y. So when I do this, derivative of y is dy dx. Here, I have two things multiplied, so we do product rule. The derivative of the first times the second plus the first times derivative of the second. How do you do the derivative of a natural log?
1 over the.
So that's 1 over y, but chain rule times derivative of the inside. Derivative of y plus derivative of x is 1. Okay? From here, I need my dy dx's on the same side. Okay. X times 1 over y, so that would be x over y dy dx. Over here I had my natural log of y plus 1. Both of these have a dy dx. So if I factor that out, that leaves us with 1 minus x over y. So then to get dy dx by itself, we divide. So we have the natural log of y plus 1 over 1 minus x over y. Now, there are a few things that I've told you I want you to simplify at the end. One of them being we don't want to leave a fraction in a fraction. So to fix this, we just look, we have a y in the second denominator. So I'm going to take everything times a y. So if we do that, we get y, natural log of y, plus y equals y minus x.
It's just silly answer.
It is a silly
That is
answer.
definitely someone like texting you that your kids like
Um,
projectile.
35x to the 6th over 32y to the 7th,
I could have. Oh, interesting. I didn't.
because you have to subtract it
I
from the
didn't.
other
I
side.
didn't see. I skipped too many steps.
Are there any logs on this?
Yeah, you can expect it. I mean, we just did one that had a log in it.
Well, are
There's
you
a
gonna make
couple
us
throughout here.
Log it from log to natural log, or is it already gonna be a natural log?
Am I going to make you log it from log now? What?
From log to ln.
Oh, they'll probably be LNs. Okay. Number 5, we didn't ask about that one. You should get 7 plus 8x squared y cubed over negative 6x cubed y squared. Or you could have all the signs opposite. Do I need to work that one out? Number 6 is on our list, probably because it's a second derivative. So we have 3x squared plus 3y squared equals 8. So derivative of 3x squared becomes 6x plus derivative of 3y squared becomes 6y, but what else does that need? Equals derivative of 8.
That was not correct.
So we can divide over or subtract over the 6x. And then we divide by 6y. So the 6 is canceled. So we get negative x over y. That's our first derivative. Did you guys get to that point? Okay. So now we do the second derivative. So we're doing the derivative of this thing. So the dy dx becomes d squared y over dx squared, or y double prime if you use that notation. We have to do quotient rule. So low d high, derivative of negative x is negative 1, minus high d low, derivative of y dy dx over low squared. Okay. Y times negative 1, so negative y minus negative, so plus x times, but then I look, dy dx is negative x over y. So that gives me a negative y. X times negative x would be negative x squared over y divided by y squared. But what don't I like about this? Fraction and a fraction. So our fix is to multiply top and bottom by the same thing. So let's just take everything times a y. So if we do that, negative y times y is negative y squared. Negative x over y times, negative x squared over y times y is just negative x squared. Y squared times y is y cubed.
How is dy dx equal to negative x squared?
That's what we got when we worked our first derivative. Other questions? All right, number 7. This is probably the ugliest problem on here. And you know how ugly it was? It was something else, and I widened over my answer key because I worked that one. I was like, oh no, that was really bad. So I widened it out and changed the problem. So you got the nicer of my uglier problems. There you
I
go.
thought this one was easy.
So we have 2y squared equals x cubed plus x squared. And I want second derivative again. So derivative of 2y squared. derivative of x cubed, 3x squared, plus derivative of x squared is 2x. So dy dx is 3x squared plus 2x over 4y. So that's our first derivative. I want the second, so now I do the derivative of that. So it becomes d squared y over dx squared. Quotient rule. So low d high, derivative of the top becomes 6x plus 2 minus high d low, derivative of 4y is 4 dy dx over low squared.
This problem was really easy because I skipped the second half of my problem.
That's beautiful.
We ended up with 24xy plus 8
No wonder it was so
over
nice.
something.
Okay. I had a lot of people asking, like, do I have to multiply this stuff all out? You don't necessarily have to. I did on mine. It's kind of up to you. If I want to distribute my 4y through, that's not a big deal. So that's 24xy plus 8y. Over here, I'm going to hold off for just a second. dy dx is all that over 4y squared is 16y squared. Okay, so those first two terms, if you left it as 4y times that thing, that's okay. If you multiply it out, that's great too.
I didn't even do quotient rule. I just plugged in my dy dx. Called it a 10.
All right, now, what can I reduce? The 4s. Okay, so at this point, I have a 24xy plus 8y minus 3x squared plus 2x twice, so you can FOIL it out. You're welcome to just leave it as squared, but it is still divided by y. So what do I have to do now? No fractions in a fraction, so I'm going to multiply everything by a y. So we get 24xy squared plus 8y squared minus this 3x squared plus 2x squared over 16y cubed. You are welcome to multiply that out. I think I did on my answer key, but you don't have to. If you did,
I have like almost all the parts.
you distribute the negative through, so it'd be negative 9x to the 4th minus 12x cubed minus 4x squared. So I'll take either of those.
I had all the parts. I ended up with mine 24xy plus 8 over 3x squared plus 2x. So
Just missing that.
I came out pretty good.
All right, number 8. F of x is f, f, f of x. Okay. I am asking you to find f prime of 1. So first, we have to start with f prime. Okay, when you are doing derivatives, you start on the outside. So derivative of f is f prime. This is chain rule, so the inside stays the same. Times, then we work our way in. Derivative of the next one is f prime. The inside stays the same. Times, work your way in. Derivative of the next one is f prime. Inside stays the same. If you kept going, what's the derivative of x? 1. So it'd just be multiplying by 1, so it doesn't change anything. So now I want f prime of 1. So I'm changing my x's to a 1. Okay, if I start on the inside, what is f of 1? So you look in your directions, it tells us f of 1 is 2. So this is asking for f prime of f of 2. What is f of 2? So it's f prime of 3. What's f prime of 3? Okay. Work with the next one. So f prime. What is f of 1? What is f prime of 2? Okay, this one. What is f prime of 1? So 6 times 4 times 5 is 120. Oh, really?
I work from the end to end,
Oh.
and I don't ever, I just read it in one line, like I don't
You just thought through each one.
ever write any more than.
Is that one okay? Number 9, you should have gotten negative 4 over 27. Do we need to talk about that? Number 10, 1 over x plus 15 over x to the 6th. Is that one okay? Or do we need to look at it? Okay,
I just ended with the wrong sign.
let's take a look. Okay, 3 over x to the 5th, that's like 3x to the negative 5 power. So when we do the derivative of a natural log is 1 over the argument. We have to do chain rule, so times derivative of the inside. Derivative of 5x is 5. Minus, okay, here the exponent comes down, so that becomes a plus 15x to the negative 6. So 1 over x times 5, that's 1 over x, plus, you could leave this as 15x to the negative 6. I just dropped my x down to the bottom, since I already had a fraction.
I never pulled my exponent up. Okay, I left my thing on the bottom. So I
Then
did
you have to do quotient rule.
But I ended with a negative, not a positive.
Because this negative could just...
Oh, because my negatives, you don't know.
Because you counted the negative on the 3.
Oh.
And so, it really should say out here which would be that positive 3 and then 2 negatives. Alright. Number 11. We didn't ask about it. Do you want me to come back to these if we have time? We asked about 16, 17, 18. Let's jump back there and then we can go back to some of the others if we need to.
Is tangent to the 4th x, would that become 4 tangent to the 3rd? But you changed it.
Tangent to the 4th x means you have tangent of x to the 4th power. So we have to do product rule and chain rule within it. So derivative of the first is 3x squared times the second plus the first derivative of the second. So the 4 comes down, inside stays the same. Subtract 1 from the power times derivative of the inside. Derivative of tangent. So we get 3x squared tangent to the fourth, plus, I'm going to go ahead and multiply those, so 4x cubed, tangent cubed, secant squared.
For some reason I thought maybe this was an old rule that the 4 was just like, it could be in front tangent. Where did that, was that when it was tangent x to the 4th? Am I making up this rule in my brain that you could just pull that?
I think you're thinking about the derivative where the exponent comes down, but you're subtracting over power.
I swear you could pull an exponent, in some way, an
It's when a number was to an exponent, but the
You're
exponent
thinking-
was an x.
I think you're thinking about logs. If you have like the log of x to the fourth before it comes down. Is 16 okay? Let's look at 17. So I'm going to treat this 5x cubed as one thing. Then I have the secant of 4x to the fifth. So we do product rule. Derivative of the first, so 15x squared. Second one stays the same. Plus the first. Derivative of the second. How do you do the derivative of secant?
secant tangent.
And when you do that, the angle doesn't change. So each of them get the 4x to the fifth. But we have to do chain rule. So times derivative of the inside. What's the derivative of 4x to the fifth?
20x to the 4th.
As far as the simplifying on this one, I would prefer, if you have numbers multiplied together, we can do that. So we get 15x squared, secant of 4x to the fifth. You can write that in parentheses if you want to. It's not wrong if you don't. This would be 100x to the seventh, secant 4x to the fifth tangent. Again, parentheses are optional, they just help us see a little better what we have here. Are you ready for 18? So we do the quotient. So low derivative of sine is cosine. Angle stays the same times derivative of the inside. Derivative of 8x is 8.
Ooh, large.
Minus high d low. Derivative of cosine is negative sine. Angle stays the same times derivative of the inside. Derivative of 5x. Low square. Okay. So when we do that, we could pull our coefficient forward. So we have 8 cosine of 5x, cosine of 8x. Here, two negatives make a positive 5 sine 8x and 5x.
Can you,
Cosine squared
If
by
you left it in the parentheses, is that wrong?
No.
Okay.
can you just, for my brain's sake, explain how you are distributing, like with your colorful line, show me how you're distributing that negative?
this.
Yes.
This is a negative 1. So if you take 1 times negative 1 times 5, you get negative 5. So it's minus negative, so plus 5.
I'm just giving it
All right, those are all the questions you guys asked. Out of the ones we haven't worked, give me a problem. Which one do you want me to work? Huh?
Can you just work like a log one? Like,
Yeah, do you want to go back and work number 14? Or number 11, sorry. We didn't do that one.
well, like the actual.
Oh, with a,
with log one.
A log log.
I knew you were gonna say that. I don't know how I knew that, but.
Okay. So, if I asked you to do this derivative, the derivative of a log is just like the derivative of a natural log in that it's 1 over the argument. The only difference is on this denominator, you have to throw in the natural log of the base. So this is the difference. When you have an ln, you don't need this term. If it's any other log, you have to throw in an ln of the base on the denominator. And then we still have to do chain rule, so then times the derivative of the inside, which is just 10x.
Wait, so when do you not add a natural log?
If you already have a natural log, you start with a natural log. But you don't do the derivative of the natural log.
Mm-mm.
You add it. Okay.
I mean, technically you could put it on all the others, but if this were a natural log up here, what is,
Natural log by natural log.
it's
is
a natural
1.
log of base e, and natural log of e is 1. So that's why we don't have to have it if it's already a natural log. If it were any other log, you just throw in that. So if I said like y equals log base 2 of x to the 7th, then what would my derivative be?
1 over x to the 7th times ln 2 times 7 x 6. We open up new tools.
Didn't mean to.
You know what I mean?
And then you could
Yes.
reduce.
Can we do some lower trig functions?
Mm-hmm.
What if we forgot to, like, what if we forget to cancel out the x's all the way?
That probably would probably be a half point mistake. Kind of depends on how many points the question is worth. But most of the basic simplifications, like if you forget to multiply 2 coefficients, I'm taking off a half point there, as long as you have them all. Okay, so something with trig functions. Okay. If I gave us this product rule. So derivative of the first, derivative of sine is angle stays the same, but we'll have to do times derivative of the inside. So this all represents the derivative of the first times the second one. Plus the first times derivative of the second one. Derivative of cosine, negative sine, angle stays the same, times derivative of the inside is 3. And then all you could really do is pull your coefficients forward. What else? I can, if you have a specific type of problem, we can make one up. If you want problems off the study guide that we haven't worked yet, we can look at one of those.
Can we do like a second derivative?
You trust me to make one of those up?
Oh, yeah.
Okay.
100% trust.
We didn't check 9 if you want to try 9.
Oh, that's true. Do you want to work number 9? Or did you guys all get it?
I got it.
Okay. Well, let's just trust.
Do a second derivative
So-
of natural log?
We weren't gonna have to do that on that test. A
Um,
second derivative of natural log?
find.
I think we didn't do it in class. We won't do it on the test. I don't know.
So, first derivative, derivative of 2x squared minus y cubed, and that one needs equals derivative of 5.
Sure.
So then I divide by my negative 12y cubed x over 3y cubed. So that's our first derivative. Now, second derivative. So low, 3y cubed, d high, derivative of the top, minus high, d low, derivative of the bottom, it's 9y squared, 2y dx, over low squared.
That 3 on that line is gonna turn into a 9, correct?
No.
It's gonna be a 6?
Power to power you multiply.
When do you you never square it?
So we have 3y cubed minus 9xy squared times, if we plug in dy dx, it's x over 3y cubed. Over low, so 3 squared is 9, y to the 6. We could reduce, so give me a 3, I could cancel out 2 of my y's, so 3y cubed minus 3x squared over y, divided by 9x, or 9y to the 6, then what?
Cancel out your 3.
Well, I just did 9
Oh,
divided
for
by
that,
3.
for that, okay.
So if I take multiply y, 3y to the 4th times 3x squared over 9y to the 7th, we can do one more thing.
Yeah, 3.
Yeah, everything's divisible by 3.
Now when I do my relaxing stuff, plus my look at trig.
That was a
You can
beautiful
what?
makeup.
I get to look at trig now